The purpose of this project was to create a password-based locking system with the LPC 802 development board. The locking system would take a 4-digit input as a password to be authenticated. The password is set by loading the 4-digit combination into the electrically erasable, programmable read-only memory, or EEPROM, of the LPC 802 so that it doesn't get erased upon boot up. In order to set or reset the 4-digit password, someone knowledgeable about the program would need to reflash the board with the new password. As you can see, the peripherals of this locking system are the 4x3 matrix keypad, where the 4-digit password is inputted, the confirmation button that is pressed if the password is correct, 2 LEDs, a red one that flashes 3 times if the incorrect 4-digit password is put in, and a green one that will light up for a couple seconds if the password is correct. On the back, there's an SG90 servo motor that opens the cover of the box. The system reads the keypad inputs by polling. The working principle is very simple. Pressing a button shorts one of the row lines to one of the column lines, allowing current to flow between them. By looping through the column lines instigated with a timer, the system can find out which button is being pressed. For example, if key 4 is pressed, column 1 and row 2 are shorted. If key 0 is pressed, column 2 and row 4 are shorted. This concept pertains to all 12 buttons, though the asterisk symbol and the pound sign are not usually used since they're not digits, though that possibility is still available within the system. The password is authenticated by a function in the board that reads the input and saves it into memory. When 4 digits are read into memory, it checks the memory-loaded password for authentication. If the password is correct, the board drives a servo motor that spins the cover 180 degrees to allow for access of anything inside the box. If incorrect, as mentioned earlier, the red LED will flash 3 times and the polling process for the keypad is reinitialized. The servo motor contains a small DC motor connected to the output shaft through the gears. The output shaft drives the servo arm is also connected to a potentiometer. The potentiometer provides position feedback to the servo control unit, where the current position of the motor is compared to the target position. The servo motor functions by sending a series of pulses to the signal line. For the SG90 servo motor, which is the one I'm using in this locking system, the pulse must be high for approximately 2 milliseconds for the servo to reach its 180-degree mark. You cannot see now because the cover is closed, but the box has a false bottom. That splits the box into 2 separate parts. The bottom part, hiding all the circuitry and LPC 802 board, and the top part, which will hold the object that the person wants to keep safe. On the left side of the box, there is an entryway for the power supply to the board, as it will need that power to operate the entire system. Behind the box, there is a small door cutout that allows access to the board for debugging purposes if anything were to go wrong. As we all know, debugging is an extremely crucial portion of working with microcontrollers, so never forget to have access to the board. So, since the system is explained, let's try it out. To begin, I'll start with a demonstration where the password is incorrect. Let's try 1234, the password you definitely don't want to have. As you can see, the red LED flashes 3 times, indicating that I put in the wrong password. Also, you can see that the confirmation button does nothing because the password was wrong. Now, we'll put in the correct password. I aptly chose it to be 3215 as a dedication to this course. As you can see, the green LED turned on for a couple seconds, indicating that the password is inputted, and it's correct. Afterwards, we push the confirmation button and the signal to the motor opens the box. Now that the box is open, we can get anything we want stored inside, or we can put anything we want to in. For now, the locking system protects my watch, but I can easily switch this out with anything else I want or add in something. As said before, all the wiring is hidden underneath the false button to give that owner peace of mind, not needing to see any circuitry, and also leave as little outside factors to the circuitry as possible. Also, this allows for a clean aesthetic for the system, not displaying any of the internals.